Okay, now it's your turn to have a go. So I'm now going to put you on Uranus. You're on planet Uranus. You're going to fire a cannonball vertically upwards at 39 meters per second. Gravity on Uranus is this 8.69 meters per second squared. So when you fire it up, it will reach its maximum height, and then it will start to free fall again. Now find out the height. Find out the height after 7 seconds. Okay, so remember, jump to your velocity time graph, and then you've got to do some stuff with this graph in order to find out the actual height here. Find out the height. Okay, so press pause and have a go. Okay, so jump to the velocity time graph. Hang on, velocity time graph. So velocity time graph. So your velocity time graph would look like this. Okay. Um, let me think. The next step is to find out the equation of this line. Well, this point here will be the initial velocity at time equals 0. So at time equals 0, the initial velocity is this. Okay, is 39. Now, gravity is always acting on this cannonball, and gravity on Uranus is this. So if you look at the line here, the gradient would be negative negative this, because we've taken going up as positive. So anything that's acting in the opposite direction would be a negative. Come up with the equation for this straight line. Well, a straight line, we know it's y equals mx plus c. Now m is in this case is the negative acceleration, is the acceleration here. So it will be negative 8.69 x plus what? Plus c. Well, c is this. Okay, c is the intercept, which is 39. Now tidy up the equation right there. Now tidy up the equation. So velocity equals. Now let's switch these two around. So it looks neater. Okay, so it'll be 39 minus 8.69 t. So this is our equation for this straight line. Now we want to know the time at maximum height, because what we're going to find out the time at maximum height. How long will it take to get to the maximum height? So at the maximum height here, the velocity will be the up and down here. The up and down here will be 0. Okay, so put 0 into this v. So it would be, hang on, 0 equals 39 minus 8.69 t. So now it's just a matter of finding out t. So add this thing to both sides. Okay, so it will be 8.69 t equals 39. Now get t on its own. So divide both sides by this. So t equals 39 over 8.69. And then that, jump to a calculator. 39 divided by 8.69 equals 4. Let's round off to one decimal place. 4.5. 4.5 seconds. Okay. So t equals 4.5. So to get to the actually let's round off to two decimal places. Sorry. 4.9. Yeah. So this will be the answer here will be 4.9. Hang on. 4.49. 4.49. Sorry. Yeah. So this time here, the time to get to the maximum height is 4.49 seconds. Okay. Now, because I but by the way, if it takes 4.49 to get to here, then the time it takes to do this up here and down again will be 2 times this. It will be 2 times that, because if you think about it, the area underneath the area underneath the line graph represents a distance traveled. Now, if it has traveled this distance to maximum height, then going down, it will sweep out the same area. It will sweep out the same area, and the only t that's available would be twice this time here. Well, it just doesn't matter if you don't understand it, but the t here is well, this from here to here is the same as from here to here. Okay, just accept that. If you don't understand it, don't worry about it too much. Okay, where were we? So we've got the time it takes to get from here to here. Now remember, we are trying to find out at 7 seconds. Now, if you get this times by 2, calculator, clear it, 4.49 times 2 equals, equals 8.98. You see, when it would go up here, maximum height, it would take 4.49 seconds to get to the maximum height. Now, and then when it hits the ground, the time will be 8.98 seconds. Okay, but the thing is, we want to know the height when it's somewhere in between. Well, this somewhere in between is at 7. So find out the gap, the time gap, if you like, between the two here, between the 7 and the 4.49. Okay, so the time gap, the free fall, if you like, is what? The free fall time will be 7 take away this thing here. Okay, so time of free fall, hang on, time of free fall, remember, free fall is when it has reached its maximum height, and then gravity just, well, it would just free fall down. It would just free fall. Okay, so the time of free fall will be 7 take away this thing here. So time of free fall equals 7 take away 4.9. Okay, so that will be 2.1. Okay, so 2.1. So time of free fall will be 2.1 seconds. So it will free fall for 2.1 seconds. Okay, so to find out this height here, we got to find out the maximum height, the total height, and then we take away this height here later on. Okay, so let's find the maximum height first, and then we will find out how far it has traveled, the distance covered by the free fall. Remember, when it's free fall, it's this, gt squared over 2. Okay, actually, let's find out the time of free fall first. So the time of free fall is this. Find out the distance covered by the free fall. Okay, so h, remember, whenever you have a free falling object, jump to this equation straight away. Gt squared over 2. Now the time of free fall is 2.1. So you got to put that in there. Okay, so gravity is 8. Gravity on Uranus is 8.69, and then we've got to times it by the time of free fall, 2.1 squared. Okay, and then we've got to divide it by 2. So this h here represents the distance covered by the free fall. Okay, later on we've got to get the distance of maximum height and then take away this distance here. But let's carry on with working out the distance of free fall. So here, calculator, clear it. Hang on, clear it. So I'm going to do 2.1 squared. I can't find squared on my calculator. So 2.1 times 2.1 equals that, and then times 8.69. 0.69 equals this, and then divided by 2 equals this. So the distance covered by the free fall would be 19.16. 19.16. Okay, so that would give us this distance going down. Now the distance of maximum height, the maximum height will be the area of this thing here. Okay, so let's do maximum height, max height equals well, get this times this and then divided by 2. So it would be 39 and then times by 4.49. Okay, 39 times 4.49, and then we've got to divide it by 2 because it's a triangle here. Okay, so divided by 2 and jump to a calculator. Clear. Okay, so 39 times 4.49 equals this, divided by 2 equals this. So 87.56, round off to 2 decimal places. So remember the distance to get to maximum height. Take away the distance covered by the free fall, it will give us the height. Okay, so height after 7 seconds equals what? Equals the maximum height. Take away the distance covered by the free fall. So this is time of free fall. So I should have said the distance. So this is the distance covered by the free fall. Okay. So take away 19.16. So 19.16. So that equals, calculator. And then take away 19. Well, hang on. 87.56. Hang on. Let me do it again. 87.56. Take away 19.16 equals 68.4 meters. So this is your answer. Okay, so the trick is the trick is to draw your velocity time graph, and once you've got your velocity time graph, the important part is to find out the time it takes to get to the maximum height, and then because you want to find, well, later on I'm going to give you a time where it's beyond, well, it's before the maximum height. So in which case you would just work out this area here rather than working out the whole thing and then taking away this area here. Okay. By the way, I always ask you to find out the distance to get to the maximum height, and then jump to the free fall, gt squared over 2, and then jump to the free fall, and then get this distance, take away this distance. There is a more efficient way of doing it, but the reason why I'm asking you to do it this way is because I want you to actually see what's going on. To actually, I just wanted you to do it this way because I want you to be able to visualize what's going on. But later on, there's a more efficient way, which I will show you at a later stage. But for the time being, if you want to find out this height, then just get this distance, take away this distance. Now later on I'm going to give you, well, if it takes 10 seconds to get to the maximum height, I will ask you to find out the distance when is that? Let's say 6 seconds, so it's before the maximum height. Okay, alright.